Okay, let's see the solution of test number 26. The question is, consider a long solenoid with Y density N have a current I passing through. How can we increase the magnetic field inside the solenoid? First, increase the length of solenoid while maintain the value of N. Second, reduce the radius of the solenoid while maintain the value of N. The third choice, increase the Y density N while maintain the length of solenoid. Or the fourth choice, none of both. Okay, this question is very simple. Once we know the expression or the formula of the magnetic field inside the solenoid, we have discussed this in detail in the lecture. So I will write down the expression for the magnetic field inside the solenoid, which is B is equal to mu naught Ni. Here N is the Y density and I is the current that passing through the Y. You can see that B depends only on N and I. Mu naught is a constant. So it means that to change the value of B, we need to change the value of N and I. So in this question, it's asked how can we increase the magnetic field inside this solenoid. It means that if we want to increase the magnetic field inside the solenoid, we need to increase N or I or both. Okay. Other parameter has no effect on the magnetic field. So for the first choice, increase the length while maintain the value of N. If N is fixed, it's no change of I, means that it's no change of B. Reduce the second choice, reduce the radius of solenoid while maintain the value of I. So you reduce R, but R is not in this expression. So reduce R will change nothing, will not change B. Okay. Increase the Y density N while maintain the length of the solenoid. Okay, here we increase N. Right? If you increase N, B will increase. Okay, so we can see that the choice, the third choice, the choice number 3, is the correct choice. If you increase the value of N, you may maintain the length of the solenoid or not, but if the density, the Y density of the solenoid increase, you will increase the magnetic field.